Greetings to everyone in a fitting manner. I'm sorry
I'm deeply sorry.
that this part of the series took too long, but I have a lot of stuff ongoing around the house, which I will show you eventually. Just a short recap. I want to control the temperature in every room precisely. The controlling must be done from my home assistant. The controllers must cut power via power over Ethernet. All the design files are available for free. The schematic and the PCB can be found in the OSH Labs website, and all other stuff from the previous videos are on my GitHub project. You can find the link in the description. First of all, I had to thank OSH Lab because after I published my project on their website, they reached me out that I'm fulfilling the requirements of the OSH Lab Stars initiative, so they can help me reducing the fabrication cost. After I screw up the initial sign-up process, they were very helpful, and the guy named Bob helped me a lot to make this happen. If you have any project worth publishing, check out the details, which is also applicable to 3D printing and CNC stuff as well. In this video, I will show you the new PCB, which are already arrived. You will see the printing and the preparation of the box with the complete assembly of one of the TRVCs, which includes the programming of the ESP32 via ESP Home. I will also show you why I am using monochromatic light in the code and not a simple switch, which I mentioned in a previous video. So let's roll the intro. So here is the PCB. This one just came fresh from JSC PCB, and I have to assemble it. So as I mentioned in the previous video, I usually use friction connection for the programming, but now I will solder in these two extra parts because it will be easier to program it in a video than I just do some sketchy stuff. But first things first, I need to break down these two side stuff. Okay, if everything good, then I should be able to put this inside the box. Yeah, it just fits perfectly. Okay, so of course I cannot use any rules. I mean, the rule is you start with the smaller components, but eventually those are soldered in already, so yeah, it's not gonna happen. So okay, it looks nice. No shorts. Okay. The next one is this programming enable, which eventually must have the jumper to program, and it's easier to solder it. So okay, this is a sheet joint, but the connector is in place, so I can do this much more better. And then I am able to looks like this is the GND because it's sucking down the heat. Okay, and this last part. This connector is also needed. Okay. The download is not needed, but before we program it, we have to set the voltages. Oh. Okay. Here we are. I need an Ethernet cable. Okay. So $19. 33, okay. Okay, almost 5. Yeah, it is good this way. So I think that's it. So my cat is here, so you may hear him. Okay, the ground is with the ground. RxDX is okay. The switch is in 3.3 volts because we don't want to fry the ESP32, the jumper is actually here. So we need to plug it in and hope for the best. And actually this one will be the same as for example this room. Yeah, I need to think because there are two kinds of TRVC, I mean the valves, the actuators actually normally open and normally closed, and I have normally closed in my drawer. So I will copy one of them. Okay, so new device. This will be the front kitchen. Connect. And we need to wait. How opportunistic. Want. Okay. So what I usually do, I copy the other ones here and start reducting replacing these sections. I also need to replace. Yeah, I'm mixing up English and Hungarian because I eventually use English in this presentation, but yeah. So it will be kitchen. One. This is just a hint what pins are occupied and what are not. I'm trying to avoid the strapping pins, which is a whole other story. But yeah. So save it. And I also I need a moment because install it via the serial connection. Just a quick unboxing, because why not? Okay. So now I will unplug, remove the jumper. That one was twigged me, let's say, once or twice. And now I should be able to okay, and got an IP address, but I like to use fixed IPs. So give me a moment, please. I'm using pfSense. So I just created a static mapping here. The IP address is here. Nice. Okay. So I would like to show you a quick demonstration why this is not a switch, but a monochromatic light in the ESP32. I need to do some preparation beforehand. Okay. When I measured, I'm not used this one, but another kind of thermostat, which I will not use again. But hopefully the effect will be the same. Maybe the measurements will not. I hope you can forgive it to me. So let's quickly solder this to that point. It actually doesn't really matter because it will be cut it down, so I can start to get really hot. So from here, I have 24 volts. This one and this one here. So the oscilloscope is actually measuring this 1 ohm resistor.
I'm deeply sorry.
Yeah. And in 1 ohm, the actual voltage which the scope measures is that much ampere. So if I start the measurement, so here you can see the problem, which is actually the starting current. If I reduce, so and if you look at this spike, it's more than 1.5 ampere current is going through this stuff, but eventually 24 volts with 1 ampere is already 24 watts of power, and the switch is not able to deliver more than that. So this is why it actually resets itself. So it starts a constant loop, a kind of deadlock, or I don't know. So because of this, I have to figure out something. Of course, the current actually goes down. So after this half a minute or so, we are already at 0.2 ampere. It's not that much, and it's getting lower and lower as the stuff heats up. But I will switch it off, and I would like to show you another kind of measurement. What actually happening with the controller itself. So we have to disassemble it. Three, two, one, go. So as you can see, there is a PWM going here. So switch off phase. There is a PWM with 30 seconds. So let's do it again. 3, 2, 1, go. 3, 2, 1, go. So as you can see, as the square waves are, the duty cycle of the square wave is rising and rising, the current is just start falling. So in this way you can actually trick the switch and it will work. And the switching off, I clicked it. But of course, still, it doesn't matter. And after the end, the LED is switching back. Of course, I got confused a little bit because it's working inverted. This kind of... This one is working inverted, so I don't really understood why the red start working first. But yeah, it's normally open and only closes. So when it closes the valve, it closed the water, and because of that the radiator will be cold, and of course the cold LED should light up when the radiator is cold. So normally it's in a hot state. Yeah. Okay, so it's time to do the assembly. As I mentioned, this long cable will not be needed. So first of all, I will cut it. Yeah. The other kinds have flatter cables, but this one is round. So I need to do some extra space here. Bit better. So a bit more. Or maybe not. We will see. Okay. The first task is this one. And as I promised, YouTube itching is imminent. Don't forget to like, share and subscribe and hit the notification bell. And as always, let's keep the smoke inside. Bye bye.